Hey, hi everyone. So, welcome to the new session of understanding distributed systems slash distributed processing from first principle. So, let's get into the nitty-gritties of a distributed problem statement, or let's say we abstract out like what's distributed processing or what it entails to. So, in very simple terms, you have your data size, which is more than your RAM size, and you want to process that data in the fastest way possible. This is the fundamental basic problem statement of a distributed processing system. I'll reiterate once again. The data size is multi-folds more than your RAM size, and you want to process that data in the minimum time possible. Let's look at the fundamentals that will require. So first of all, distributed processing means you have a number of EC2, or you can say that laptops that have to work in tandem to get a work done. So it simply means that you have a software. Somehow that software is installed on multiple laptops, and that laptop is collaborating together to get a work done. A mental model would be the society, how people collaborate with each other in order to get the work done and let the society and the system running. So the individual human beings are the EC2 slash your laptops and the information they exchange among each other and get the work done. The other basic fundamental would be if you look at a single laptop, the same concepts, serialization, deserialization, client server programming, and file handling or file manipulation are the three most basic component that will be reiterated across MapReduce, Spark, Hive, uh, Storm, Flink. This basic fundamental will not change. So if you have a good grasp over these three topics, plus understanding around how computers can work together to get a work done, you are good to go in terms of distributed system. My name is Kunal Gautam. I work as a principal architect with one of the MAN companies and in total have 16 years of work experience. Have worked with 50 plus customers across 20 plus countries. Have co-founded my own startup known as Windex and have presented at multiple big data and AI conferences around the globe. So let's look at the history of data analytics to begin with. So just like humans have a history and humans have created different tools and solutions for data analytics. So data analytics itself, or let's say distributed processing itself has a history. So let's begin with. So in the beginning of the time, humans started counting using your fingers. And that's the reason till now, if you say that, hey, do 5 plus 5. So people do counting 1 plus 2, 3, 4, 5 plus 5, and that's 10. So fingers people still use to do counting. And that's so primitive. It's from the beginning of the times people have been using it. A great insight. The number system was not created by Arabs. It was created by India. The Iranians took the number system and they took that to Europe. And that's the reason it was called as an Arabic number system. But the number system was created in India. Then abacus came. Most of us would have used this in our childhood. That you count. So you have the beads and you take the beads on one side and that's how you keep counting. Then what happened was set theory came in. So this is an abstract concept wherein you understand about the union, the conjunction, left join, right join. It's all represented in the set theory. I'll come back to the point. Why do we study set theory at such an early age? As the time progressed, transistors, capacitor became, ICU came into being, CPU came into being, and that's where your calculator came. Fast forward to that, laptops were invented, or let's say EC2 was invented, wherein you can host your databases. So look at the history of it. Now coming to the point, why set theory is taught to most of us at such an early age? Take a pause, think about it. Very soon you will realize that set theory forms the fundamental or provides the fundamental operation of data analytics. Just correlate that with a SQL, structured query language. You will realize that structured query language gives you the possibility of do a group by, left join, right join, inner join, outer join, Cartesian product, where clause, filter clause, right? Just map it to the set theory. You will realize that it is the same operator that is defined in set theory. And the reason being, the set theory provides the most fundamental operators, and you can derive other operations based on this and can create, or let's say, or you can achieve all the data analytical operation that a human can do. All right. So this is a fundamental idea. And again, when I say primitive and derived example, addition is a primitive operator. Integration is derived out of it. So integration is nothing but like you infinitesimally take small units and you keep adding them. That's what integration is. So integration is derived from addition. So similarly, all the data analytical operators, they are derived from set theory. So it simply means that your database is nothing but a computer science representation of your set theory. And if you extrapolate that, your Spark, your MapReduce, Storm, Flink, they are also nothing but the representation, or let's say the computer science model for set theory. Because end of the day, they provide the same operators what we have in set theory, and they provide the same operator what's provided in SQL. All right. So this is how you should be mapping. A relational database is nothing but a computer science manifestation of the set theory. Theory is like an abstract idea. In computer science, you convert that into something that people can interact with. A very important concept now, and again, one of the most fundamental concept, but this will be reused across the different services. The fundamental services, the consensus building. Example, two EC2 instances are there or two laptop are there. You have executed one Python project, Python code here. You have executed the same Python code on the other laptop also. Now I give it a number and I say that, hey, both of you decide that this number has to be sent to a dedicated other laptop, or let's say there is another Python process. Both of you decide that it has to be sent to this Python process here. Let's say there are n Python processes here to choose from. And these are the gateway Python process. So two Python processes in the gateway, and let's say there are four Python processes who can do the work. Now somehow if I set a number to Python process one, it can say that, hey, route this to Python 3 worker node, Python 3 worker process. If I give the same number to the other Python process, it has to somehow figure out, because my process one has sent it to node 3, I also have to send it to node 3 itself. It means that somehow that these two Python processes somehow have to figure out how to route the same number to the same destination. So if you think about it, if let's say they start chatting among itself, and now imagine you have thousands of router Python processes and you have billions of numbers. Just imagine, just to figure out where a number was sent, how much chatting they will have to, or how much interaction they will have to do among each other. Is there a mechanism through which, without even interacting, two Python processes can decide, or two Java processes can decide this number has to be sent to a specific node itself? So let's look at the problem statement in a very simple way. You have 5 balls on the left hand side of your screen, and you have 4 holes. The balls are numbered from 0 to 5, and the holes are numbered from 0, 1 to 3. What needs to be done is ball 0 goes to hole 0, 1 goes to hole 1, 2 goes to hole 2, 3 goes to hole 3, 4 goes back to hole 0, 5 goes back to hole 1. How is it possible that I can deterministically, just looking at the ball number, say that this has to go to hole 0 itself? And the answer is modulo operator. So modulo operator forms the basis of consensus building. Without even two machines interacting among each other, they can decide if a number comes to me, or whatever, a number or ASCII sum, whatever that comes to me, I am aware where to send this information to, even without interacting among each other, because modulo provides that deterministic way of figuring that number. Right? What is this? Take a pause. This is modulo 4. Because the remainder will come 0, 1, 2, 3, right? Whatever is the question, your remainder will be always between 0 to n minus 1, quotient minus 1. All right. So just think about it. Although it looks like a very simple concept, just keep in mind the partitioner in MapReduce, the partitioner in Kafka, the partitioner in Spark, they're all based on this modulo operator. Although you are free to change it, you can use pretty much whatever you want, but I'm saying the default implementation is modulo. Because modulo says that even without chatting, even without interacting with any other machine, I can very deterministically figure out where this information has to be sent. So this decreases a lot of chatter. And when I say chatter, it means simply client-server interactions are happening. I don't have to do like billions of client-server interaction. I just need a number comes, I can just do a model of that and I can figure out where to send that. Let's quickly jump onto the code of it and see what's going on there. So this is a small class, create ASCII sum class. Something interesting I would just love to show you. So this is the modulo operator, number quotient, or let's say modulo by the divisor. It is the remainder or the quotient, right? Oh, sorry, this will be divisor minus one, not quotient minus one. I'm really sorry for that. Just a quick takeaway here that hey, just know that computers have something known as the ASCII sequence, wherein every character, not the number can be represented as a decimal format or the binary format. Just keep in mind, every character that you see in the computers don't understand character because computers are at the CPU level. The instructions is only to do number addition, subtraction, multiplication, comparison, or the relational operator. Computers don't understand characters, words, paragraph, or sentences. That's a human notation of it. People can only understand. Computer has no idea of it. So what is happening is every character that you see on the screen, it's mapped to a decimal number. Example 1 is mapped to 49, A is mapped to 65 decimal number. And when it gets translated, it gets converted into binary and computers can process that. But what I want to say is this is just a mapping. If I say 65 in decimal, I want to say convert that to a string or a char, it will be converted to caps A. And you can see here, caps A and small a are all different. Just keep that in mind. So we can do is we can take a string, example, a word here, and we can return what is the sum of all the numbers because let's say it's like apple. So we can say, hey, just go to this chart, figure out A for apple is 65. So A is 65, P is LMNOP, 80, sorry, a small p, right? So A is 97, small p is 112, right? So apple is like whatever, 97 plus 112 plus 112, blah, blah, blah. So that's how you're able to do a sum of the characters of a string, right? Just keep in mind, this is purely relational, saying that this corresponding rather, right? A corresponds to capital A corresponds to 65, P corresponds to 112. So all I have to do is I have to just add those digits and I will get the ASCII sum of it. All right. So this is doing the ASCII sum, and what this operator is doing is it's just taking the modulo. So you give it the number, which is the ASCII sum. You give it like, hey, by what I have to do the modulo of it, I get that, and I can just return back what is the answer for it. Just keep in mind, Apple and EPPAL or any other combination that you have, like if you jumble them, they will all result into the same ASCII sum and the same modulo. So what it means is there can be different numbers can point to the same modulo. But a given number modulo, the question will always be a constant factor. So two key takeaways. If Apple arrives at two different nodes, both of them know that if my quotient is in this case like 11, then 3 will be the remainder, right? So in that case, if Apple arrives on node 1 or let's say Python process 1 or Apple arrives in Python process 2, both can do a modulo and both will arrive as 3 as the output. But also keep in mind EPPAL, EPAPL, they will also result into 3 only. So somehow people have to be smart enough to distinguish which was Apple 3 and which was EPPAL 3. We'll figure out when we go for a deep dive into MapReduce or Spark how this is taken care of. But the most important thing to understand is how the consensus building has been done without two processes interacting among each other, and that's the beauty of modular operator. Just keep in mind, folks, this is one of the most fundamental concept of distributed system. If you have understood this aspect, let's say 25% of your distributed system is done and dusted. With this, I'll meet you in the next session. Till then, take care. Thank you. Bye bye.